Welcome back. So if you've noticed, we've got quite a stack of projects. We've got our external service projects, the Google API. We've got our middle tier projects, business logic layer, cache, data access layer, domain models. We've got our presentation project. We've got now a new thing, a test project, and we've got the service layer. So this is about testing. How do you test things? Like, where do you insert a test? How would you test different elements? Okay. So what I did was I created a test project called UTVolunteer BLL. If we remember, the way we set up the end tier, the presentation layer is calling cache, cache is calling business logic layer is calling data access layer uses the domain, to go to the database. Um, it's probably not a bad idea to have a UT plugged into each one of those layers. In other words, let's get rid of presentation. We'll think about that later. We'll go from volunteer to cache. We'll go from the UT to business logic layer and the UT to data access layer if we wanted to test every single layer. Right now I just created one for going against BLL. So all I did was I created a new folder called test projects, right click add. I added a new project. I went up here in the search and I typed in test. There's a couple different test projects you can do. So if I said Visual C and I said test and hit enter, I'll get a bunch of different projects. The one I did was the unit test project for Visual C. We'll talk about the other ones, not just mock, but the coded UI test project we'll talk about, and the managed test project we'll talk about later. But this is just the simplest one, unit test project. When you include that project, there's nothing much to it. It's almost like a console application. It does come with a couple of references. There's a reference for the unit test framework. There's probably a reference for system. Now, a couple of things I had to tweak with this to get it to work. One was obviously you're going to have to inherit the logic layers that you need from the middle tier project. So I had to make a reference to the business logic layer and to the domain model. So that's a no-brainer. If we were testing cache, we would go against the domain models and cache. If we were testing DAL, we'd go domain and DAL. The next thing is, the way this works is it needs the entity framework because I'm going to be using entity framework objects. So I had to use the tools library and package manager, and I had to do a get on the entity framework. One line command and it installs it for you automatically. The other thing I had to do was I had to create, and you don't get this with it, I had to create an AppConfig, right click, add, new item. Again, you can search and just type in config. It's an application configuration file. Double click that, you'll get an AppConfig. It's pretty much empty. Here's what you do. Go to the business logic layer and just steal the AppConfig from here. Literally cut and paste it. What it needs is this. It really needs the connection strings. So you're trying to access like data objects and it doesn't know where things are. So you need to just copy and paste the BLL, the AppConfig and BLL. So that's all I did. I have AppConfig from BLL. I've got the references. I added the entity framework. I added the business logic layer and domain models. And it always gives you sort of a class to begin with. And I renamed it. I called it UTVolunteer. So let's take a look at this. Let me close some things away. So here we go. I added a using for our two namespaces. And I have one method in here called create volunteer. Notice this is something new. Let me expand this. There's a public class UTVolunteer matches this. It's a test class. Underneath this, I have a test method. This is sort of new naming conventions. This and this. Not quite naming conventions, it's called a format. That's what the test framework looks for. So we know what the different modifiers are for methods, public, private, protected, and so forth. When you put this in front of it, that's like exposing that public even more public. I hate to say it like that. Let's look at the service reference. It'll make more sense when you see the service. I'm looking for not this one, the I. There we go. So remember this thing in service contract and operation contract. You see how it has that sort of, it's like it's string, but on top of that, an operation contract. Where'd that come from? It's like modifying it from an outside project. So that's what test that test class and test method says. So either way, so this is new. Everything else is the same. Same sort of naming, same sort of how classes work, how methods work, same modifiers, and the rest of it, right? So what does this do? This create volunteer. Simple. Let me take off the breakpoint so we can read it. I create a new instance of the volunteer domain model. I create a new instance of the business logic layer. That volunteer domain model, I gave a name. I called it Jim Morrison. What's another name? Janis Joplin. I'm into the Doors tonight. It was on TV while I was doing this. Anyway, Janis Joplin. I call the insert method in the BLL. I pass over the vol. It returns back to me the same vol. This is a pass by reference because I'm passing an object. So if I pass by reference, what's the purpose of this insert volunteer? The insert volunteer is going to eventually figure out what the volunteer ID is. It's going to put it back into vol and then return it back through the call. Let's take a look at the data access layer for that. Volunteer. Here we go. Expand. Here's the insert for volunteer. I'm passing over the volunteer object. I probably don't need this in there anymore because it's not passing it in. It's generated. So it's going to ignore this. I hate to say it. Over here, I'm passing in the first, middle, last name, and active flag. And here, I'm saying save changes. Once this save changes is run, it will return back the vol ID in that context here. This is me adding that vol ID back into the object that I passed, and me passing that object completely back through the chain. So when I'm back on this line, that vol ID has a real vol ID that's in the database. All right. So how do we run tests? Let's collapse everything just so we can read it. And here we go. A right-click class. Go to Run Tests. It's going to compile. It's going to give me a warning I can care less about. It's compiling and building. It's successful. After it builds, and it successfully builds, it will run the unit tests in the background. This one doesn't take very long. It takes a couple seconds. If this wasn't hosted externally, it would take a millisecond. Comes back in 9 seconds, says, hey, it passed. So when it says it passed, I don't have any assertions in here. I'm not really testing anything yet. All I wanted to see if this actually worked, right? My assertion is that I got a vol ID that came back. So for right now, let's to really know if this worked, let's go to the output. And I've got a standard output. Can I make this any bigger? I really can't. Let's take a look at the database. The database says there's Janis Joplin, no middle name. I have a default of 1 for active. It's a GUID. The last 4 are 6B83. 6B83. So I know that it created. Cool. So how do I test this? So first of all, there's no way for me to really give an assertion other than this passed or failed. The only thing this is going to do is generate a vol ID. So a good unit test is something that you I did this wrong and right at the same time. This record the Janis Joplin record should not have stayed in persistence. By rules of unit testing, I'm setting up a record, and at the end of this, tear down. So I'm expected to clean up my mess. I should be having not just a create method here, but I'll change the record, I'll make sure that worked, and then I'll delete the record. Either manually or through the delete method. I really shouldn't leave any records in persistence. I just did it just to prove to you that it did work. So what's a proper unit test? Let's say the test is, let's say I'm going to add, I'm adding methods to add a phone number. Now remember, back in the back end, phone number is related to volunteer. Should be related to volunteer. I don't see it. So phone number. Imagine, imagine if you will, if phone number was related to volunteer. What I would do is create a new volunteer out of the blue. I'd create a new phone. I'd associate the volunteer to the phone. I'd do an assertion to make sure that those records stayed in persistence. Then I would delete the association. I'd delete the volunteer. I'd delete the phone. I'd end my unit test case. Excellent. If there was a way for me to test math, I may say, so what would be a good test with this? If I ran this insert when I'm sitting on this line where the blue rectangle is, that record is inserted, I may want to count the records that are in the volunteer table with a vol ID of whatever this vol ID that was passed back. Whatever this vol ID was passed back. If I count that table, I should get 1. I shouldn't get 0. I shouldn't get more than 1. I should get 1. I really can't test by looking for a count of Janis Joplin because there could be more than one Janis Joplin. I can by the vol ID because I know that's unique. Excellent. That's pretty much how to set up unit test cases. Now, what's powerful about unit test cases, if you write them correctly, a couple things. Number one, you could do test-driven development, i.e., I can start from the test side and write test cases for my development that I need. I could have a test case that says, and I'm just writing things in here, I can have test cases that say test phone, test address, test skill, and set up a bunch of different classes to do all this work, test phone and address and skill. And then the coding has to beat the test cases. So if I write my test cases first, and I had them ready, in other words, I don't compile it with this because it won't compile because the work isn't done yet. The test cases have to succeed in order for the project to succeed. That's number one. Number two, if I make these persistent, I can have the build of the project dependent on the successful unit test cases. So imagine if I had a build project that's building this whole nonsense and pushing it off to the servers. I can have that build dependent on that test class and these methods. So when I do a push every day at noon, it'll run these methods and test classes. If they all work, it pushes correctly. If it doesn't, it stops. It makes me fix the test cases, and by their fixing the test cases, fix the code. Very powerful stuff. This is not exclusive to Visual Studio. Certainly, Java has the same thing. They have Java JUnits or JTests, but you can also You can have Maven, which is the build machine for Java, be dependent on those test cases working. Excellent. I hope you learned a lot. I posted the results, or excuse me, I posted the code for this under GitHub. Do a commit, do a pull, and pull the latest, and you should get it. See you in class. Bye.